Going to look at some properties of our integral. So how we can manipulate integration, basically make life a little bit easier for ourselves. This first one basically reinforces what we saw yesterday. If we integrate, what we're basically saying is find the primitive function. So when we're talking about a polynomial, add 1 to the power over the power. And it's called a definite integral because we're substituting values into it. So we'll end up with a definite answer, be some value. This is highlighting that you can factorise. The integral symbol is a grouping symbol, just like parentheses and so on. However, you can only factorise out constant values. You cannot factorise out the pronumerals that you're integrating. So only pull out constant numbers. The third one is basically saying you do it a term at a time. So if you want to find function x plus or minus g of x, you could integrate function x and do that one, sub in the values, integrate g of x, sub in the values, add them together, you'll get the same answer. If you want to integrate from a to b, you could integrate from a to c and then integrate from c to b and add those two together. It'll give you exactly the same result. Yeah. Now, most people tend to say, oh, but c has to be in the middle. And c doesn't actually have to even be in the middle of the two numbers. C can be any number and it's still going to be true. But yeah, traditionally, it's sort of when we're splitting it up and it tends to be in the middle. But as I say, it doesn't have to be. It could be any number. Now, what's this one saying? The integral is greater than 0. What does that mean? Well, if the function is always above the axis. So what I was basically saying is if the function's above the x-axis, you will always end up with a positive value when you substitute in. If it's below, then you will end up with a negative number. If you've got two things you're integrating, and you would look at the pictures on the number plane, the integral of the function x will always come up with a lower value than the integral of gx if, on the picture, function x is below g of x. Makes sense when you think about it, because we're talking about area under the curve. So if function x is below g of x, well, of course it's got less area below. And that's what we talked about yesterday as well, about the limits. I mean, most people tend to put the larger one on top. You don't have to. But if you do swap them, which you're allowed to do, no reason why you can't, you make sure you change the sign. Odd functions. If you integrate an odd function from minus a to a, so the symmetry, you'll end up with an answer of 0. That comes back to what we said before, is if the curve is above, you'll get a positive number. If it is below, you'll get a negative number. So if we get in the symmetry, it's going to be the same number, but one's going to be positive, one's going to be negative. It will cancel out. If you think of area, have a look at the cubic over there. If we were integrating that from, say, negative, oh, I don't know, it doesn't really matter, negative 2 to 2, the actual areas would be the same. But one area is below, one area is above. So the actual number it comes up with, the one below will be a negative value. So odd functions from minus a to a will always give you 0. Even functions, because that has reflectional symmetry, can be done rather than going from minus a to a, twice from 0 to a. Why do we do that? Well, sometimes 0 is just a really easy number to substitute in. And so instead of going minus a to a, we go, oh, well, let's do twice 0 to a. So as I say, if it's an even function, we can take advantage of that. And when you're looking at functions, keep that in mind. If you've got functions multiplied together, odd function times an odd function will give you an even function, odd times even will give you odd, and even times even will give you even. So basically, if it's the same type of function, when you multiply them together, you'll get an even function. If they're different types, you'll get an odd. And if you forget that, bring it back to the simplest polynomial. The simplest odd function you'd know would be x to the power of 1. Okay, so let's say it's x. Simplest even function, oh, I was going to say a constant number, but okay. X squared would work. But you substitute that in. Odd times on. Oh, x to the power of 1 times x to the power of 1. Oh, it's x squared. That's even. Odd times even. X to the power of 1 times x to the power of 2. Oh, x to the power of 3. That's odd. So if you ever forget, you can always take it back to the basic, simple one. Okay, let's do some examples. Integral of 6x squared Well, I can factorise the 6 out if I wanted to, and just integrate the x squared. And of course we get a third x cubed. And now I'll factorise the third out, and we get 2 lots of 2 cubed minus 1 cubed. Cube root of x, gonna have to put it in index form first. So that is x to the 1/3. Be real careful with fractions. Add 1 to the power. So add 1 to 1/3, we get 4/3. Over 4/3, it's easier rather than writing a fraction on the bottom, invert and multiply. So write it as 3/4 x to the 4/3. I find it easier to do it that way. Sub in 5, sub in 0, again 4/3. If I want to come up with an answer, an exact answer, unless the number's nice, I'll convert it back. So 4/3 is 1 and 1/3, so it's x times the cube root of x. Sub in 5, I'll get 5 times the cube root of 5. We don't know what the cube root of 5 is exactly. So if I'd gone to my calculator on that, it's just going to give me a decimal approximation. Now, if the number was nice, I mean, if it was just the number 1, well, I wouldn't worry about that, because I know 1 to the power of anything is 1. Yeah, no need to. So my final answer there, 15 times the cube root of 5 on 4. Hang on a sec. Integrate trig, we haven't talked about that yet. But this is using another idea. It's equal to 0. Think of the sine curve, the picture of it. It's an odd function. So you're saying it's power of 5, odd times odd times odd times odd times odd. Ends up being an odd function. You got symmetry, minus 2 to 2. So you're integrating an odd function, symmetric, answer 0. Once we learn some techniques on how to actually integrate those, much time can be wasted with a question like that. Because people see the integral of sine of 5 and they think, oh, right, got to integrate sine of 5, and they use all the different techniques to do it. And don't spot the symmetry, and they see, and that's how quick the question is. Oh, it's 0. Now, another one people sometimes miss. This can be simplified. Again, you've got symmetry there. And you're looking at that polynomial and you say, well, it's not odd and it's not even. But we have another rule that says you can do it a bit at a time. So I could rewrite it like that. You see, x cubed, when I integrate that one, it's an odd function. I know that bit's going to be 0. 2x squared, that's an even function. So I can go twice from 0 to 1. X, that's an odd function. Disappear. 1, that's an odd function, so I can go twice 0 to 1. So I can simplify that integral to just be twice the integral of 2x squared plus 1. Add 1 to the power over the power, substitute in, there's our answer. I mean, if you don't spot it, obviously it's still going to give you the same answer, but yeah. Okay, 11C.